examine virtually every facet of modern manufacturing, whether it's how you operate, integrate into supply chains, design and make products, or how your customer use the products. Cloud manufacturing is helping manufacturers to innovate, reduce costs, and increase your competitiveness. Big companies such as Honda Motor Company is also inseparable from using cloud manufacturing technology in their system. Honda Motor Company is Japanese public multinational conglomerate corporation primarily known as manufacturer of automobile, motorcycle and power equipment. Honda has been world's largest motorcycle manufacturer since 1959, reaching a production of 400 million by the end of 2019, as well as the world's largest manufacturers of internal combustion engine, measured by volume, producing more than 14 million internal combustion engine each year. Honda became the second largest Japanese automobile manufacturer in 2001, and Honda was the 8th largest automobile manufacturer in the world in 2015. The cloud manufacturing technology used by Honda is virtual manufacturing. Virtual manufacturing is a computer-based technology for defining, simulating, and visualizing the manufacturing process early in the design stage. With this technology, manufacturing-related problems can be detected and addressed quickly. Honda Motor Company used virtual manufacturing to simulate the Honda production process from conception to customer delivery. It also used as a platform to design, process, and experiments during manufacturing verification, including product, process, and resource function.
Moving on, application. Honda uses the 3D Experience platform, a system designed by Dassault Systems, for design and trial processes during manufacturing verification, including its product, process, and resource functions. For product, Dassault Systems' CATIA software allows Honda to virtually simulate its cars to ensure specific plants can build vehicles as designed. With the software, Honda is able to see any vehicle and guarantee that its plants have the contents and resources they need to build each specific variation. Dassault Systems CATIA enables Honda plant managers to view the product build and sequence and apply it to the actual plant. Because all of Honda's plants carry different resources, this step is particularly important. Next is process. Honda's legacy process tool was only text-based. While it was a valuable tool for engineers at the time, Honda could not take advantage of the 3D data R&D produced, and the 2D data was difficult for process planners to visualize. To correct this, Honda needed a software solution that could process 3D data quickly and simply. By working with Dassault Systems, Honda created a tool that could pull data from its legacy system as a starting point and allowed process engineers to easily make changes. Additionally, the software clearly outlined part consumption, ensuring plants had the correct parts for the vehicle variation they produced.
Okay, for resource, because Honda plants are all built differently, the company used plant. To create the simulations, Honda used an AEC application to bring each plant into contact, reflecting the kinetics, conveyance system, and entire work area. The visual model allowed Honda to preview how its product will move through a specific plant and to visualize if certain conveyor model will work across plant. Using Dassault System 3D Experience platform, Honda Visual Maturation team was able to move its verification process from strictly physical to primarily digital verification, which has enhanced the company time to market and productivity.
Further, difficulties and challenges part. Application of the cloud manufacturing brings a lot of convenience and benefit to company. However, to implement the cloud manufacturing in Honda, which face some difficulties and challenges. There are several challenges in cloud manufacturing paradigm of Honda. First is the deployment cost. The cost of ubiquitously deploying manufacturing resource could be huge. It needs a huge budget to set up cloud manufacturing with hardware resource, manufacturing capability, and software resource. Second is privacy and security aspect. The valuable and confidential data goes into the cloud outside the firewall. Hacker may have a hand trial to this confidential data. Exposing this data outside is critical. The data privacy is concerned because it is stored elsewhere and being monitored by someone. Next is the demand uncertainty. Customer demand are not predictable due to this COVID-19 disease cause the demand uncertainty influence the effectiveness of production planning. After that is the unwillingness to adopt cloud manufacturing technology. Social and employee are acceptable awareness of cloud manufacturing technology is inadequate. They are less understanding for the cloud manufacturing technology and seldom touching this knowledge. Therefore, the legal issue also as a challenge of Honda to implementation the cloud manufacturing. In cloud manufacturing, stakeholders should transfer corresponding data through wireless network or uploading data onto the web that may result in data disclosure. They will cause a legal dispute among the stakeholders. In the nutshell, is the knowledge and trust management of company. Cooperation of two factories to manufacture a product requires a scalability and interoperability of both factories and their mutual trust. This is because the demand from a factory are converted to a product able to another factory for manufacturing. This process needs a scalability and interoperability of both stakeholders and relies on mutual trust.
Okay, moving on to countermeasure and solution for the challenge. The first problem is the deployment cost. For the countermeasure, Honda chose a mid-market cloud company called ICM Phoenix, which operates in 5 UK data centers in Glasgow, Leeds, Birmingham, London, and Farnborough. This will reduce the overall budget in implementing cloud manufacturing to the company, as high-market cloud company tends to be expensive in their service. Next is the privacy and security. An advanced persistent threat (APT) doesn't understand which computers normally talk to which other computers, but the user does. Slowly take the time to track the network flows and get a good handle of what traffic should go from where to where in order to catch the hacker. The next one is the demand uncertainties. For the countermeasure and solution for the demand uncertainties, the demand cannot be fixed easily due to the pandemic. The demand will recover when the COVID-19 pandemic ends. During this time, the Honda company can target customers with stable incomes to ensure that the revenue of the company does not drop severely. Next one is the unwillingness to adopt cloud manufacturing. Okay, since business are adopting the cloud strategy more often than ever, it is imminent that the workforce should keep up and carefully address the potential cloud-related issues by learning the usage of cloud manufacturing bit by bit. Next is the legal issues. Honda needs to look for vendors that can provide compliance and check if they are regulated by the standards they need. Some vendors offer certified compliance, but in some cases, additional input is needed on both sides to ensure proper compliance regulation. Lastly is the knowledge and trust management of companies. For these countermeasures, make sure the Honda SaaS provider has real-time monitoring policies.
As a conclusion of this study, we can assume that we have now reached a point where everyone can use VMs. It seems that VM would stimulate the need to design both for competitiveness and efficiency of production. It can help enterprise predict various problems in the production process. Nowadays, even if there is a lot of work to do, all the pieces are in place to become a standard tool for designing the production process for virtual manufacturing. Such as computer technology is widely acknowledged. The concept of virtual prototyping is widely accepted. Business need quicker cost-saving or time-saving solution. Leading businesses are already demonstrating the successful use of virtual manufacturing technique for more precise simulation. Nevertheless, we hope that there are still some hindrances to be more successful for a complete integration of VM technique, data integrity, training system integration. Moreover, if large manufacturing enterprises have sophisticated and apply with success VM technology, VM is capital-intensive technology and a lot of SMEs do not have the resources to integrate them. We should closely follow the advancement trend of virtual manufacturing technology in the world and vigorously establish our virtual manufacturing system. In addition, we should also frequently study the new technologies in various engineering and other fields to aid support the future development, especially in industrial automotive.